Hi all, welcome back to my channel. If you are new to my channel, consider subscribing my channel and hit on the notification bell so that you will be updated as soon as I uploaded the video. And also follow me on LinkedIn where I'll be providing the slides for the topics that I'm explaining it in the YouTube. Okay, so in today's video we are going to discuss about what are verilog ports and how are we going to connect the verilog ports. Okay, so port is nothing but it is an interface to communicate with other modules. Okay, basically when we want to communicate with other modules, so as I already told you, verilog is nothing but it's a combination of various modules, is it or not? So when you want to communicate with other module or with a test bench environment, you will be using the verilog ports. Okay, I'll be discussing about what is test bench and all in the upcoming sessions, don't worry about that. Okay, so in verilog you will be having mostly three different types of ports. One is input, output and in-out. Okay, these are three different ports that we be using in the verilog. So again, when we are going to declare the port, how are we going to declare the port in verilog? Okay, we'll be declaring it in three parts. Like first is port direction. Port direction means whether it is input port, output port or in output. Okay, this is the keyword for input port declaration, and this is for output, and this is for in-out. So basically whenever we want to declare something, we'll be declaring it in this way. Like first direction, like which direction it is, whether it is input, output or in-out, and then followed by data type, whether we it is rich data type or wire or anything like integer. Okay, so and this data type is optional, like we can declare it or based on our usage whether we can declare it or not, it is our wish. Okay, this port data type, like whether it is rich, wire or any data type that we are using in verilog, we can declare it, but this is optional. And then coming to signal name, signal name is nothing but, for example, a comma b. So these are identifiers. Identifiers are nothing but, I have already discussed about what are identifiers and all in the lexical tokens topic. You can go there and check it out, what is the identifier and all. Okay, so this is how we'll be declaring the port in verilog. First is direction of the port, and the second is data type, and then the third is names of the port, like every port will be having individual name. Okay, so this is how you will be declaring the ports. Okay, so see here, basically these are types of ports. Like first is direction, and then here if you didn't mention any data type, like as I already told you, it is your wish to define or not the data type, and then the identifiers. Okay, so identifiers are nothing but names. Here it is having three ports, so these are identifier names like ab. And this is how the vector representation, I have already discussed about what is scalar and vector also. Okay, you can check there, like what is scalar and vector. So this is the vector representation, and if you see here, this is the scalar representation of the port. Okay, in this way you will be declaring the ports. First you should remember that you should write the direction of the port and then the identifier name, and if necessary you can write like any data type. Okay, this is how you will be declaring the port. So see, and one important thing while you are declaring the port is that, so every port are implicitly declared as wire. So basically in connection, in port connection rules, while you are these are some of the rules you can say. Okay, that means every value is having as in verilog, as I already told you, every value will be having its default thing, like every data type or anything will be having its default value. Similarly, ports, while you are declaring, basically every port is implicitly declared as wire. That means whenever because why it is, because why it is considered as wire, because basically ports are used to drive the values, is it or not, communicating. In this first slide we have discussed, like port is an interface in order to communicate. So communicating means what, it is used to pass the value, is it or not? Communicating means passing something. Passing something means in technical language we are driving something, is it or not? So basically what is the data type that is used to drive the value? nothing but wire. So that is why basically every port is implicitly declared as wire. Okay, so based on our usage we can convert this data type into like rich. Okay, and while converting to rich also there are particular limitations. So what are those limitations? Basically input and in-out ports can't be declared as rich. Okay, why is this? So okay, let me tell you with this small example. Here, if you see here, these are input ports, is it or not? And these are output ports, right? So, in this input ports, for example, I am sending some value like 000. Okay, to this full adder. So, what is the full adder logic? You will be writing full adder logic here. What is the logic? Sum is nothing but AX or BX or Cin, and carry is nothing but AB, BC, CA, like C in A. Is it or not? Okay, so this is the particular logic. So when you are driving the values like 000, what is it happening here? The value is placed here and it will be working out, like the logic will be done, and then it is sent to output like sum and carry. So 0 0. Now as soon as this thing is over, like 0 0 0 is over, then what is happening? Again we are driving one more value, like see here 1 1 1 or 1 1 0 0 1 1. So continuously we are driving the values, is it or not? And then the logic is done, and then what is it doing here? Until the value, like after sending these 0 0 0, the output is sum is 0 and carry is 0. So what is output doing here? The output is holding this 0 and 0 until another value, like until these values are done here, like the logic is being done, and then after 1 1 is done here, then this value is changed from 0 to 1. Is it or not? So basically what is happening here? Inputs are driving the values, and output is, what is it doing? It is holding the value until the next value is placed here. Is it or not? So that is why, since inputs can't hold the value, they are used to drive the values only. So that is why, what is the data type that is used for driving the values? Wire, not ridge. So that is why basically inputs and in-out ports are not declared as ridge. They should be compulsorily declared as wire. And when coming to output, output is defaultly wire. Because why is it again defaultly wire means, we can't say that this is the output we want, is it or not? That means it may have intermediate connections, like what I'm saying is, for example, this is my full adder. Okay, this sum and carry, and then I may use another full adder or some other component here. Okay, some counter or else anything, and for this counter maybe these outputs are used as inputs, is it or not? So how could I say this is the ultimate output? Is it or not? Because it may have some intermediate connections. So that is why basically by default output is wire. But when we want to hold the value in that output, then we can declare the output as rich. But we can't do that to input. That is what I'm saying. Whenever, because input means something, it will be at the starting itself, is it or not? Like at starting what we are declaring, those are considered as inputs, right? So that is why they should always be wire. But when it comes to output, it can be considered as rich. Okay, even though defaultly it is wire, we can change it to rich, but there is no option of that, like that for wire like input. Okay, got my point? This is the port declaration. And again, while we are declaring ports, we can declare it in two ways. Like there are two methods. We can see it as like initially, like in older days we used to declare it in this way, and then after the like verilog tutorial, like lsr is ls updated, then what is happening means, what happened means, we can, it is having another method, like we, this is the newer method and that is the old method. So let us see both the things. And also one more important thing is, you should not mix both the things, like you should not mix both old method and new method and write your own program. Okay, that is illegal. So what is the first method? So in this first method, module, within module and module, and this is the name of the module, you know, you have, I think you know about this, and then you will be declaring the port names. Okay, that means, for example, you are doing right like some full adder or something, so it is having some ports. Okay, so like these port names you will be declaring here, and then about the direction of ports, like which direction it is, you will be declaring inside the module. Okay, you didn't declare it with the module, but you will be declaring it inside module. You see here, input A, output B, in out C, and then which data type it is, like A is reg and B is reg. Okay, you will be declaring it like this here. Okay, port declaration. And the second method is, you can declare both direction and data type within the like module itself. See, within the module only you have declared everything. So after declaring it like this, you again can't declare it outside the mod, like outside the module. Okay, that is the important thing here. If you see, within the module you have declared only ports, you have ended it with the semicolon. Semicolon means, that means you have ended it. Okay, and then after that, within the module you are declaring it. Okay, that means outside the module. But here, within the module only, you have declared both A, B and C, like input, output, input. So after declaring it, you shouldn't declare it like this. Okay, again, if you want to declare it, you should declare it here only, like reg 7 down to 0 B. You should declare it like this. Again, you can't declare it outside the module. Got my point here? Okay, this is how the declaration is done. And also, if you see the declarations here, you have seen some invalid things here. Why is this? Because basically, if you see here, A is input. Okay, as I already told you in the before that, why input can't be declared as reg, so that is why this is invalid. And B is output, so that is why it can be declared as reg here also. Okay, here this is also invalid. Okay, input reg 3 down to 0 A. Okay, and one more thing is, what is another thing that is invalid? After declaring it here, we can't declare it here. Okay, if you want to declare this, what you should do, you should just declare it here itself. Got my point? So this is how the port declaration is done. Okay, in two ways. You shouldn't mix match both ways. That means you declare it here and then also declare it outside the module also, then that is considered as error declaration. Got my point? So this is how the two methods for declaring. And there are some key points. So key points is nothing but just we discussed. Let us see. Input ports can only have net data type. I already said that. Okay, in the newer ANSI C style, that means this is the newer version of ports declaration, and in this ports list, declare ports can't be redeclared inside module. That is what I already told you. That means once you declared it inside the within the module, you can't declare it inside the module. Okay, your own size of port declaration can't be mixed. That is what I said. Okay, default data type of any port is net. Okay, right? So this is how the thing is. So basically, this is the full adder verilog code. Okay, if you see here, this is how the port declaration. Here, this is the newer style. See, within the port module only, we have declared both ports, like input, output. Okay, right? So, and then now coming to port connection. So until now we have discussed about port declaration, how to declare a port. So after declaring the port, why is this port used? In the starting only I said that port is nothing but communicating from one module to another module, or from RTL to test bench, is it or not? So when it comes to this position, like for communicating, when it comes to communicating, what is the main thing? Connection. In order to communicate, first you need to connect it, is it or not? So that is why port connection is important. So how are we going to connect it? When we instantiate a module having ports, we need to connect it with other modules or the top module using the port. That is what I said. That means whenever you are instantiating some module, or whenever you are connecting one module with another module, whenever you are connecting RTL with test bench, how we are you going to do it? You are going to do it with the help of ports. Okay, so while calling a module, the width of each port must be same. You just remember it. I'll be discussing this point later. Okay. So, and also verilog unconnected ports. So what does this mean? So during connection, for example, when we are doing some hardware connection, okay, that means you are having a hardware and you are connecting it. Okay, so whenever you don't want that particular connection, what you will do, you will just leave the particular port like that, is it or not? So but when it comes to coding, can we do that? Yes, in verilog there is a possibility to do that. How are we going to do that? For example, if you don't want some port to connect, that means for example, if you see here, this is the full adder example. Okay, here what will be actually sum and cout, is it or not? Okay, sum and cout actually, and abc are the inputs, right? Now you don't want this particular cout to be connected with anything. You don't want to connect that particular carry to anything. Then what you can do, you can just leave the white space in that particular place, so that it is remained as unconnected port. Okay, basically in hardware what you will do, you will just leave that you don't connect any wire or anything to that particular port, and it is left unconnected. So when this comes to coding, like when it comes to software, we can also do it by just leaving the white space there. Got my point? So this is called as unconnected port, and it doesn't give any error. That means when you have left anything like with white space, then this is considered as that the port is, that there is some port there but it is unconnected. If you doesn't leave any space, like you are giving it like this without any space, then it will throw you error. Okay, so that means it should know that there is some port there and that the port is left unconnected. Okay, so for that simulator to know whether there is some port there or not, you should leave some blank space, white space, that means one space. Okay, basically this is the port connection thing. So now, okay, in this port connection, that means connecting the ports, is it or not? So this connection is nothing but we can also call it as technically mapping. Okay, in technical word for connection is nothing but mapping. Okay, this port mapping can be done in two ways. One is by order, the second one is by name. This is really important because by using the connection of ports only, we can communicate with anything, any module or any test bench. Okay, so that is why port connection is really important. Okay, so let us see one by one, like what is by order and the second one by name. So by order means nothing but connection of each port in the same order. What is the order? That we listed in the module declaration. Okay, that means, let me tell you with this example so that you will be understanding. We have already discussed about the module instantiation and all in the previous classes. So if you don't listen to module and module instantiation, just go there and check it out, like module, what is module and module instantiation, and then come to this port declaration. Okay, so coming to this module declaration, if you see here, this is my parent module and this is my child class or child module, you can say. Okay, this is my parent module and this is my child module. That means this is, see, this is my actually 4 by 1 mux. Okay, now I am designing my 4 by 1 mux using only 2 by 1 muxes. Okay, so this is my mux 1, mux 2 and mux 3, right? So what I'm doing, I'm just writing a simple 2 by 1 mux code, and then what I'm doing, I'm copying it like 3 times here. Okay, I have already discussed in the previous classes. You can go there and check it out, like what is this copying and all. So in this copy, what I am doing here, if you see, each copy is having an individual name, and if you see here, these are inputs for my parent module. like SEL, I naught, I1 and Y. And if you see here, are there any inputs that are similar to this? No. Why? Because basically every module, every mux, if you see, is having individual inputs and individual outputs. Is it or not? But the logic is same here. Like if you see, the logic is same for this mux and this mux. Okay, let me give you a small example for this. Let us consider you are taking some material. Okay, some study material is given to class, okay, by some teacher, and it is asked to take xeroxes. Okay, for example, if there are 10 students and 10 students are having the xerox copies of the same study material. Now, in these 10 students, what is the same thing that is there? The study material. Okay, the material is same for all the 10 students. In the same way, the parent module here is same for all the instantiations here. The logic is same in all the instantiations here. This is the logic is same for all the instantiations here. But what is it that differ? So your all in all these 10 students, what is the thing that is different in the study material? For example, if you are having study material, you will be writing your own name, you will be writing your own registered number, and you will be highlighting your own key points. So this makes your study material differ from others. Is it or not? In the same way, in this particular parent module, the logic is same, but what is it that is differing? The ports are differing. Okay, just like your name and your register number and your key light points are highlighted points are differ from other students. In the same way, in all the active copies here, the inputs are the things that are different. Okay, so that is different. So this connection is important here. First method is what I told you, connection by order. That means here, just like the order that you have given in the parent module, you have to connect the modules. Like SEL1 means this is select here. Okay, this is I naught here, this is I1 here, and this is Y here. Okay, so select one is placed at SEL1 and I1. Nothing but what is it? I1, I3. I3 is placed at I0 is placed at I2. Fine. So this is my first thing. And when coming to second, what is it? Select one. Select one is nothing but SEL. Okay, I0 is I0, I1 is I1, Y0 is Y. Again the logic is placed here. And then in coming to third one, SEL0 is SEL. Okay, Y0 is I0, Y1 is I1, Y is nothing but Y. Okay, again it is placed here. So in this way the logic is placed, and the this is connecting by order. For example, what if you don't connect it by order? Okay, let us see in another example, that one. So this is what the connection by order. Now let us see the other thing is connection by name. What is this mean? Okay, so when it comes to connection by name means you don't connect it like this basically. Okay, so what you'll do is mux to 1, okay, M1, and then you will be connecting it by name. Like if you see here, dot SCL, okay, of you will be connecting it or dot SCL to SCL1, okay, comma, dot I naught of I2, dot I1 of I3, comma, dot Y1 of Y. Okay, in this way you will be connecting it. So for this, what we can do is, in while we are connecting it by order, we should be connecting it by order. Like since you have given first CL and I naught I1 Y, so you should follow that order while we are connecting it by order. But when we are connecting it by name, what does this mean is we can do it like this also. We can write it like this. Since we are connecting it by order, we don't need to follow the order. Like you can just write it I1 of I3, I naught of I2, okay, dot SEL of S1. Even though you are doing it like this, even though you're not following order, since you are writing it with name, it will be connecting it to that particular module on port only. Got my point? So this is what port mapping by order, port mapping by name. So as I already told you, what if you don't connect it by order? Nothing will happen, just your output will be mix matched. Why? Because if you see here, this is my instantiation. Okay, now what are the things that I have ordered? How did I order it? Like A, what is my order in the parent module? A, B, C in, sum, C out. Is it or not? Now what is the order that is following here? Sum, C out, A, B, C. Nothing happens. A is connected to sum, B is connected to C out, C in is connected to A, sum is connected to B, C out is connected to C. Simple. Now what happens? Everything will be mismatched and your output will be a wrong one. Okay, so this is how the port connection is very important. This is one more example for this. Okay, just check this example, and if you are having any doubt in this particular example, you can comment me in the comment box so that I'll be answering you. So these are some of the examples, like this is port connection by order, port connection by name. Okay, so this is how basically port connection by order and port connection by name will be taking place. Okay, so this is all for today.